Ah, Olá, boa tarde. Eu sou Wendy. Desculpe minha apresentação com antecedência. Eu queria fazer em português, mas ainda não falo muito bem português. Y voy a tener mi cámara desligada porque tengo miedo de parto. Mi presentación es sobre estudios de caso. Comienzo. Eh, what is a case study? Case study is a research methodology typical seen in social and life science. There is no one definition of case study research, however, very simply. A case study can be defined as intensive study about a person, a group of people or unit, with each aim to generalize over several units. A case study has also been described as intense systematic investigation if a single individual group, community, or some other unit with the researcher examining in depth data related to several variables. Professor, sorry, I speak very fast. In English and Spanish, I speak very fast. Well, let's start talking about Yago. The Yago project by Sushanen and Kansei create one of the first large knowledge base that were automatically extracted from Wikipedia in parallel to Wikipedia. Yago has been maintained and advised by the Max Planck Institute for Informatics in Germany and Telecom Paris University in French. The KB has been used in many projects worldwide, most notably for semantic and type checking in the IBM Watson systems. Initial Yago. Yago tiene cuatro fases. Initial Yago, Yago 2, Yago 3, Yago 4. Initial Yago. Core knowledge. The key observation of Yago was that Wikipedia contained a large number of individual entities such as singers, movie, or city, but do not organize them in semantically clean type system. Wikipedia hierarchy of category was not suitable as a taxonomy. WordNet has very rich and elaborate taxonomy, but is hardly populated with instance. Yago aimed to combine the two resources to get the best both worlds. O sea, instance of Wikipedia and taxonomy, the WordNet. The first version of Yago converted every single Wikipedia article into entity and extracted classes from category of the article. To distinguish between thematic category for human browsing, Yago developed the heuristic. If the head node of a category name in plural form, there is a taxonomy class. This leaf level category were linked to the WordNet. This is extracted de Yago infoboxes que Yago extracted from Wikipedia. Aquí se puede, this image ten las categories que se pueden, can be extracted from infoboxes. Elvis Presley, American Singer, Born, Country, etc. Category Rock and Roll, American Singer, Academy Award winner, etc. This is an example. Yago extracted label for entity from Wikipedia redirect and attach provenance information to each statement. The handcrafted specification included domain and range constraint to eliminate the spurious statement. The objective was to focus Yago entirely on precision, even if this mean a lost record. The rationale was the KB with 5 million fat and 95% precision is more useful than a KB with 10 million fat and 80% precision. The objective was to focus Yago entirely on the precision. The number or state was chosen to bring the Wilson confidence interval estimate of the estimate precision to 95% plus or minus 5%. Refined by the relation, some properties included that the type property even reached nearly 90% precision. For a long time, Yago was the only major KB that came with such a statistical guarantee about the correctness. In 2008, Yago was extended with facts from inboxes of Wikipedia. These were extracted by hand-crafted regular expression for around 100 selected relations. This process also extracted the validity type statement when applicable. The HPO triplet notation was slightly extended to allow statement with temporal scope, such as Germany has DP 3,667 trillion in years 2018. By reification, the shorthand notation was mapped in pure triplet of 1. Likewise, the Yago KB was the focal point of the broader Yago-Naga project that include methods and tools for exploring research in the KB. Now I will talking about Yago 2. Yago 2.10 spatial and temporal scoping. In 2010, Yago was systematically extended with temporal and spatial knowledge. Entity and statement had time interval assigned to the node when entity existed and statement were valid. Timestamps were extracted from Wikipedia info boxes when it's possible and propagate to other entity and entities by a limited from home rule. For example, if we know the birthday and the birthday and the death day of Frank Sinatra, we can deduce the validity interval for the fact he was a person. Such rules were systematically applied to people, artifact, event, and organization, thus giving valid time about the third of the fact. This temporal scoping was in turn beneficial as a consistency check when extending the KB or binding in a new major version. The spatial dimension of Yago came from GeoNames, a large repository of geographical entities with coordinates and informative steps. To avoid duplicating the entity from Wikipedia, were matched to the entities in GeoNames by comparing name and geographical coordinate with threshold on similarity. This similar entity matching technique preserved the high quality of canonized entity. The type taxonomy of GeoNames was mapped to the class taxonomy of Yago by taking into account the name of the GeoNames class, the head noun of the name, the most frequent meaning in WordNet, and the overlap of the glosses in two resources. Similar to the temporal scoping, home rules were applied to propagate location from entity to their statement and vice versa. This KB was accompanied by a query engine that allows searching entity not just by their fact, but also by validity time, spatial proximity, and space-time combination. For example, the query George Harrison create after John Lennon will find songwriting by George Harrison after John Lennon dead. And the query guitarist born in Near Cedar will return Jimi Hendrix, Kurt Cobain, Carla Torres, and more. Recent work on argumenting Yago 2 with the spatial knowledge in the Yago 2 is the Yago 2 Geo project, which integrates content from OpenStreetMap and other sources and support very expressive query language called GeoSpark QL. The extraction pattern for Yago 2 were specified declaratively. An example pattern is this pattern, category bears, here is the el patrón. Another, this pattern extract birthday from Wikipedia category names, the next version of Yago, Yago 2, further advances the principle of declarative specification and modularization. The system was factored into 30 structures, each for a specific scope. The structures were orchestrated by a dependency graph, where each module depends on input from other modules. A scheduler could run this structure largely in parallel or a pipeline mode. the DBNJ, like a declarative machinery, proved very valuable for debugging and quality assurance, and could be new KB version very efficiently. Yago 3, tercera versión de Yago. In 2014, Yago 3 started extracting from Wikipedia edition beyond English, covering edition like German, French, Dutch, Italian, and others. The goal was to construct a single consolidated KB from this multilingual source with more entities and statements, but without any duplicate. The extractor harnessed an interwiki link between Wikipedia edition and the interlanguage links in Wikidata. For example, the French Wikipedia article about Londres is about the same entity as the English article about Londres. A difficulty to address was extraction from non-English info boxes without manually specific patterns for each different edition. For this purpose, the Yago 3 system employed a distant supervision from the English edition by statically comparing English seeds for the Sawyer-Oyer page against those observed non-English info boxes. The system could learn the correspondence between property from different zones. To construct the taxonomy, different category names were mapped to the English counterpart by harnessing interlanguage link from Wikidata. The modular architecture developed for Yago 2 allow all this just a handful of new extractor translation of non-English entity, mapping of info box attribute to relation and taxonomy construction. Downstream extractor were not affected by this extension. Another major project of multilingual knowledge we even large covered is Babel.net. This is an example from the extraction from info boxes. In bold, we can see English extraction, in light, multilingual extraction, in green, newly designed extraction model. This is an example the extraction for info boxes for Yago 3. Now, the last Yago 4. Alignment with Wikidata. Yago 3 has been continuously improved and the software became open source. However, the KB was bound to Wikipedia and the entity featured there. Thus, it became clear that KB could never reach the scale of entity coverage that Wikipedia achieved in the meantime. On the other hand, Wikidata followed the principle of included claim and statement with potential diversity of perspectives rather than in disputed factual statement only. Therefore, semantic constraint cannot be rigorously enforced. Furthermore, the large number of contributors to the Wikidata community had led to convoluted and cluttered taxonomy of classes, where an entity such as Paris is buried on the 60th on informatic classes. The cleaning of contradictory statement and the transformation of convoluted and noisy taxonomy into clean type system have been key competitor of the Yago project from the start. In this spirit, the last Yago version, Yago 4, abandoned Wikipedia as impulsor and set out to tap into Wikidata as a premium source, applying the same principles. The higher level type of taxonomy are no longer based on WordNet. Instead, Yago 4 adopts the type system of schema ORG, an industrial standard for semantic markup in web page. The directed populate flexible classes of Yago 4 are carried over from Wikidata. In this regard, Wikidata is fairly clean and coarse-grained. Most entities belong to only one of two types directly. Wikidata expresses the latter by means of various properties. Since schema ORG has only around 1,000 classes, and the overlap with immediate types of Wikidata instances is ever smaller. it was best to manually align the relevant type from two sources. Property also adopted from schema ORG with the advantage that they come with clean type signature for domain and range. The alignment with Wikidata property requires rationally limited amount of manual work. The entity Wikidata best access Western format from Wikidata to populate newly crafted KB schema. The data was completed by hand phrase consistency constraint for class disjointness, functional dependency and inclusion dependency expressed in the child language. As a result, in this constraint-aware construction project, the Yago 4 knowledge base is rational, probably consistent, and amenable to the OWL reasoner. Metadata about provenance is represented in the RDF format. This is example de Yago 4. Yago 4 browser, hover and reverse the full name of abbreviated item of all red and blue item aquí clave. Lesson learned. Yago was the one of first large KB automatically constructed from the word source. Its unit trace at the high precision semantic constraint and judiciously constructed and fairly comprehensive style taxonomy. Over Yago, 15 years history, several major lessons were learned. This learned some harvest law hanging fruit fits. Yago was successful because it focused on premium source that were comparatively easy to harvest and could yield high quality output. The category system of Wikipedia and semi-structured content like info boxes. This resulted in a human precision that was previously unrivaled by automatic method for information extraction and at this scale. Other lection focus on precision. Yago has focused on precision at the Spencer of recall. The rationale is that very KB is incomplete and that application are source necessarily prepared to receive incomplete information. Under this regime, there is no surprise if some song or city is missing from the KB. Conversely, users are confused or irritated when the contract grows statement. Therefore, Yago focused on a premium source and relatively conservative extraction method, reserving more aggressive methods for KB augmentation. The project investigated and developed a variety of such advanced methods, but this had limited impact on the more conservative release of the Yago KB. Other lesson, limited effort manual contribution. The project identified sweet spots where limited manual effort had a very large positive impact. The specification of property and their type signature is a case in point. It's not so much effort to define hundreds of property and constraint by hand. It's my price when this can guarantee the cleanness and tangibility of many million statements. Other, modularized structure. There is enormous value in burden the KB construction coded into a smaller structure modular, each with a specific scope. This allows declarative orchestration of entire extraction assemblies and greatly simplify, maintains the debugger and project life. Use OpenStack. The adoption of OpenStack like RDF, RDFS, etc. Standard books that use and utility of the KB resource and API by wider community and research development. This includes the representation of statement. In early Yago, many questions arose about the syntax of KB statement. Character coding, reserved character, state convention, etc. This could have been avoided by early full adoption of RDF. The second case study, Divipedia. Divipedia started in 2007, was the only early project to construct a large-scale knowledge base from Wikipedia content. Divipedia is spearheaded by the idea of linking open data, LOD, a network of data and knowledge base in which equivalent entity and interlinking by the same as predicate. The LOD ecosystem has grown to the 10,000 of sources with Divipedia as central hub. Divipedia target InfoBox attributes right from the beginning. Every design attribute was cast into property type without manual curation. Thus, Divipedia could not apply domain and range constraint and other steps from canonicalization and cleaning. In return, Divipedia can capture all information of Wikipedia InfoBox and thus provide much larger coverage than Yago. Over the next year, the project also extracted further content, abstract image, interwiki links between different language editions, redirect labels, category name, geocoordinate, external link, and more, becoming a Wikipedia structured form. In 2009, Divipedia started organizing the entity into a smart handcrafted taxonomy, driving the most frequent InfoBox template on Wikipedia. It also specified clean property type for these classes and manually mapped the InfoBox template onto property. To keep its high coverage, Divipedia stored both the raw InfoBox attribute and the selective curate one. All in all, Divipedia offered 4 different taxonomy: the Wikipedia category, the Yago taxonomy, the onboard taxonomy, and the handcrafted Divipedia taxonomy. Another novelty in 2009 was Wikipedia Live, a system that continuously processes the change the logs of Wikipedia and fix them into the KB as incremental updates. This image shows the architecture of Divipedia Live. Here we can see the pivotal element of the system is the tripper store for HPO trippers. By using tripper store, instead plain file, Divipedia can handle live update directly via SPARQL. The triple store can also provide the data in different formats to different consumers. Wikipedia is ingested into form by DOMS and delete field of Wikipedia. The Wikipedia page are handled by a number of extractors, much like described previously for Yago, intended with parser for day, measure, geographic coordinates, and number. Depending on the origin, the structure statement are then sent to one of 2 destinations: simple triplet DOMS or SPARQL updates. This system will sustain up 2.5 Wikipedia page update per second, while Wikipedia has an update rate 1.4 page per second at that time. Over the next year, the project built up an intentional community of contributors and added many useful tools, including SPARQL endpoint, another APIs, as well as the Spotlight tool for name and entity recognition and disambiguation. A separate Divipedia edition we create for each around 100 language edition of Wikipedia. These Divipedias are independent, but volunteers in different countries mapped InfoBox attribute of non-English Wikipedia to the common Divipedia schema. Finally, Divipedia deals with the rise of Wikidata, but incorporate its entity and property while keeping its genuine taxonomy. Mapping between Wikidata property and Divipedia scheme were manually specified by the community. Since 2014, DBpedia is run by the DBpedia Association and organization with regional charter in 15 countries. Now I will talking about other case of study, NEL. The never-ending language learner, NEL, by initial letters, starting in 2010 by Carlson, Bittenrich, Kirsel, is a project at Carnegie Mellon University to build knowledge base ab initio from any kinds of word source. NEL distinguishes itself from the other KB project by its paradigm of continuous running over the many years. The idea being that the KB is incrementally grown and the underlying learning-based structure will gradually improve in both precision and recall. The key principle to tackle this ambition goal is coupled learning. Less has learning for several tasks, and these tasks are coupled to support each other. For example, learning that Elvis is a singer, Elvis Presley is a singer, reinforces to the confidence is an instruction that Elvis relates a certain album, and vice versa. Nurses start with manually create a schema with 300 classes and 500 binary relation with type signature. NEL Bootstrap is learned with a few tens of labor training sample for each class and each relation, for example, guitar for the class, music instruments, Colorado for the class River, etc. The structure run on in a large pre-clouded web corpus with the following central learning tasks. Type classification, relation classification, synonymy detection. Synonymy detection is giving a pair of noun phrases detect whether they denote the same entity. Example, Big Apple, New York City are synonymy detection. Son equivalentes. Severa supervisor classify an employee using future like a string similarity or co-occurrence with pairs of no phrases entity dimension. Other tags sería rule meaning. NEL can be learned and restricted for home rules as soft constraint, such as if two people are married, they live in the same city. These rules are used to predict new statement and to constrain nose candidate statement. This learning and inference tasks are coupled. Result of one task serve as training sample, counter example, or constraint for other tasks. NEL have more than 4,000 learning tasks and more than 1 million instant constraints. This image shows a high-level view of NEL architecture. Just like Yago and DBpedia, NEL hosts different types of extraction module. Aquí se puede ver. We can see extraction module. Unlike the two other systems, though the NEL module extract from sources completely different nature. Natural language text, table, embedding, image, and also human input. The central element of the architecture is the feedback loop between the KB and the extraction modules. The modules delivers belief candidates. These are consolidated into belief, and this serves to retrain the modules. To implement this retraining, NEL runs in infinite loop of two alternative steps, which are loosely modeled after the EM, expectation maximization algorithm. In the E step, NEL estima the probability of each statement in its KB by combining and reconciling the input from different learners. In the M step, This confidence refines the KB used to retain the learner to avoid semantic drift, human intervene from the time to time, and correct aberrant pattern of the statement. Overall, NET has led more than 100 million confidence binary statements, include around 3 million with high confidence. And for this schema, NET has also some need for discovering new relations to be added to the ontology. This is based on the path ranking algorithm, which computes frequent edge label sequence on path of the KB graph for view discovery and rule learning. The head of newly learned rule can be interpreted as a new predicate. The NET website allows visitors to give feedback about a statement, which not only correct error but also provide cue for future learning route. NET could be proactively solicited feedback on accepting a statement via Twitter. Last but not least, the NET project also considers a limited form of introspection, automatically self-reflecting on the weak spot in the KB by ensemble learner. The confidence of a statement and rule can be estimated in calibrated way. This way, the learning machinery can be steered toward obtaining more evidence, counter evidence on low confidence belief and weight rule. Lesson learned by NET and challenge. To overview, article provides specific reference for all these methods. The learners and the potential extension. It also discusses lesson learned. The overarching insight is the NET principle of coupling different learners allow it to achieve good result with a small number of training samples for bootstrapping. Constraint at the key to take notes and arrive at high confidence statement. NET is also facing a number of open challenges. This challenge will be beware of the long tail. Prominent instance of classes and relations are learning fast, but is less frequently mentioned instances are more difficult to extract. This led to the problem of when the cutoff, the extraction, and more generally how to cope with the inevitable trade-off between precision and recall. The NLKB is essentially a probability distribution over a statement and rule with a long tail of low confidence belief. Interpreting this uncertain KB is a challenge for downstream application like a query and reasoning. Other challenge, learning coverage. Another challenge is causing the never-ending learning, which makes it hard to where some task is completed. For example, the world has only 2,000 countries, but now we continue trying to find more learning experience, statement and rules on learning, then later is on. Entity canonicalization. Also, NET can learn to identify synonymous entity name. It has insufficient support for entity linking to ensure unique representation for entity. This canonicalization is an obstacle for some downstream application. This was the challenge and lesson learned for NET. Now, I will talk about Wikidata. Wikidata is a collaborative community to build and maintain a large-scale encyclopedic KB. It's currently the most comprehensive endeavor on publicity and accessible knowledge base. Wikidata operates under the auspices of the Wikimedia Foundation and has close ties with other Wikimedia projects like Wikipedia, Wiktionary, and with Voyage. As of August 2020, the KB contains 88 million entity and has 23,000 active contributors. For this survey article, 3 aspects of Wikidata are especially relevant. The way how knowledge in Wikidata is organized, the way how the scheme involved in this collaborative setting, and the role the Wikidata plays a huge for entity identification interlinking between datasets. Wikidata was launched in 2012, following the early experiment with collaborative data space such as Semantic Media Wiki. The motivation for collecting and organizing structured data in the Wikimedia ecosystem was twofold: centralizing interlanguage linking and centralizing InfoBox data. Wikidata should be used for automatically generating this across a Wikipedia language edition, thus simplifying maintenance and ensuring consistency. As of August 2020, the first goal has been reached, and the second one is getting closer. The population of the Wikidata KB started out with human contributor manually entering a statement. In 2014, Google offered the content of it, then phased out free-based KB for possible import into Wikidata, 3 billion statement, about 50 million entity. The Wikidata community refrained from automatic import from quality assurance. Instead, a tool was created to allow editors to validate individual statements before insertion into the KB. As a result, around 17 million statements, about 4 million entities were added to Wikidata. This small fraction of the enormous volume of free-based underlying the very high quality standard that the Wikidata community exercise, including the requirement for reliable reference to support a statement. The rapid growth of Wikidata is subsequent years have been largely based on his human contributor, but also use full import with human in the law for quality assurance. Beyond the Wikidata-centric user, it turned out that Wikidata became useful for many other purposes, as well interlinking in and enriching data from public libraries and archives, and managing biomedical and scholarly data. Now I will talk about data model and KB life cycle. Wikidata model revolves around entity, SPO triplets and qualifiers. Entity called item in Wikidata jargon have language independent Q code identifiers. Aquí, here we can see un example of Wikidata page from Singer Bot Dealer. SPO triplets can claim a statement about entity. Following the RDF model, soldier are entity with Q code and object can be entity of literals. The predicate come from manually specified set of about 7,000 properties identified via language agnostic people. This predicate space and the entity ally are continuously and collaborate expanded by the contributor in the Wikidata community. Wikidata circumvents the restriction and simplifies knowledge representation by reification and by qualify for definition SPO types. Qualify, I predicate and read deeply with the content about the source, deity, reason, etc. Now I will talk about the taxonomy and consistency. Wikidata items are organized into subclasses by use of the instance of property, which in turn are organized using instance of and subclass of. There is no hard distinction though between instance and classes. For example, Buddha is both an instance of religious concept and subclass of religion ecstasy a person. And the latter layers to subclasses like soldier, alien, item, individual. The complexity, difficult, interpretability, and potential inconsistency of Wikidata class system was specifically addressed by Yago 4. An important principle of the collaborative community is allow different perspectives. Therefore, Wikidata refers to a statement as claim. This not necessarily capture a single view of the world with universally agreed upon fact. Rather, it is possible that alternative standpoints are inserted as separate statements for the same entity and property. Wikidata also supports a rich portfolio of consistency constraints, including type constraints for property, functional dependency, and more. However, by the philosophy of capturing potential conflicting cases, the constraints are not rigorously enforced. Instead, they serve to generate warnings when entering new data. So it is up to the contributor to respect the constraint or not. Also, user can systematically look at constraint violation and make correction in deemed appropriate. The KB life cycle, like Wikipedia, Wikidata follow a collaborative process under which both data and schema continuously evolve. For inserting entity and statement, an important criterion is to include reference to reliable evidence. Schema edicts, on the other hand, are typical subject of community discussion. Frequent issues are, for instance, whether a proposed property type will be reused often enough, whether a property could also be expressed by class membership, and what kind of constraint should be imposed. Regardless of initial intention to support Wikipedia, Wikidata now holds statements about many entities that are not present in Wikipedia at all. This is largely data imported from so-called GLAM. GLAM is acronym for Galleries, Library, Archive, and Museum. GLAM. And government organizations that provide open data. Typically, this involves adding an entity, like a book author or public school, and set of statements for this identified in the original data source. The data import goes through semi-automatic process, first discussed and approved by the community, then carried out by PUT. Typical uses for approval are whether the data is of sufficient interest for a KB at all, how data quality is assured, and how to interlink the new data with the existing content of the KB. Import procedures are supported by a variety of tools, such as Open Refine and Mix Match. Application of Wikidata. Wikidata is utilized a range of applications in galleries, libraries, archive, and museum GLAMs. These stakeholders are major proponents of open interlinking data. Their entity, like author, artists, and their work, are increasingly captured in Wikidata. Typically, we identify the point to the original repository. For some entity, this identifier constitutes the majority of the statement in Wikidata. GLAM have been high interest in such interlinking opening up the content for collaborative enrichment and better visibility in search engine. Other application is in scholarly knowledge. Knowledge about scientific publication, author, and their organization is another use case that is gaining importance. Besides existing projects like CTC, Semantic Scholar, Scholia is a Wikidata-based project. Is aimed to provide tools for semantic analysis of a scholarly topic, author network, bibliometric measure of impact, and more as open alternative and value-added extension to prevalent service like Google Scholar, Microsoft Academic, or publisher service. Other application is entity identification. Another desirable purpose of KP is to provide master data for entity identification and cross-linkage between resources. Other application is licensing knowledge. The license is a domain where Wikidata has potential to become a data hub. On the other hand, the Wikidata KB contains a large amount of statements about disease, drugs, protein, etc. On the other hand, is a rich coverage of identified as linked to other repositories support combining different biomedical sources in a friendly manner. Challenge for Wikidata. Wikidata is today most prominent endeavor on collaborative knowledge engineering. Still it faces a number of challenges in its future advance. Quality assurance and content vandalism. These are never-ending concerns for collaborative projects. A good strategy requires balancing openness of contributors and moderate approvals. Allowing edit by any contributor has the risk of introducing error, but also the advantage that error can be quickly caught and corrected by others. A staggered review and approval, on the other hand, can prevent blatant error and the expense of slowing down the KB round through. In addition to vandalism concerns, are also raised over more subtle content distortion with commercial or political interests. Other challenge is involving scope and focus. This scope and focus of Wikidata are repeatedly coming into discussion, especially when the new data import are discussed. In 2019, for instance, debate revolved around the importing of scholarly data, which currently make up 40% of Wikidata entity. Such imbalance could possibly be as functionality for search and ranking and puts a strain on Wikidata infrastructure, potentially at the cost of other stakeholders. Therefore, decisions on in scope of topic are recurring concern. Other challenge, schema stability. Wikidata collaborative process and continuous evolution are better able to keep up with the evolving reality than any spare level modeling of classes and property. However, this implies the application relying on Wikidata require continuous monitoring and change. As change in property definition and taxonomy structure can break query, finding the right balance between the community's grassroots contribution and controlling the quality of stability of the KP schema will remain a challenge. Data duplication is the other challenge. Redundancy and the resulting risk of inconsistency are future issues that arise from the principle of the collaborative community. At the entity level, this well under control by the self-organization among editors, which can capture duplicates quickly and resolve it. However, redundancy is an issue for type and property. By independent edit, property can be duplicated in forward and backward direction, such as parent, child, is part of, etc. Similarly, existential information is stored in separate property. This makes querying more complex and most critically may easily cause inconsistency. To sum up, conclusion of the presentation. In this presentation, the main objective was to develop the topic of the case study for the KB. We treat some examples like Yago, Divipedia, NEL, and Wikidata. Yago is a knowledge base that unifies information from Wikipedia, WordNet, and UNAIDS into a coherent word. This presentation presents Yago 4, the newest version of the Yago knowledge base. The unique characteristic of Yago 4 is to combine the well of facts from Wikidata with the clean and human readable taxonomy from schema.org, together with semantic constraint and enforced logical consistency. In addition, I talked about Divipedia. Divipedia is a project made to extract structured content from the information created in the Wikipedia project. The structured information is made available on the World Wide Web. Divipedia allows users to semantic query relation and property of Wikipedia resource, including link to the other related dataset. NEL is the other case study. NEL introduced a new machine learning paradigm called never-ending learning. It's more machine learning application, a system made to learn a single function or data model from given data set. What is a new paradigm? The system learned the different type function from years of experience in the way that previously learned knowledge made for accumulate a new type of knowledge. And the last one was Wikidata. Wikidata is the centralized linked data repository for all Wikimedia projects. This means the Wikimedia project can put information from the same central place. This also means that a 300 language version of Wikipedia can put data from Wikidata as well. There is incredible potential for more access to information, more consistency across the different languages, and the ability for any language speaking to contribute more equitably.